from a major metropolitan U.S. city. You're literally, maybe 30 minutes, 20 minutes of drive away from parking and hiking up and having a few-hour hike, and you can absolutely feel like there is no one else around you in the world. You can have that wilderness experience where you're not seeing mechanized machinery, you're not seeing buildings, you're not seeing crowds, and you feel like you're really able to enjoy the solitude. And I think that's really unique, and it's worth fighting for.
This is the future of Utah snow, a KSL News Radio in-depth. The greatest snow on Earth, a phrase that has been tied to Utah's powder since its origin. When skiing editor Tom Korologos wrote the phrase in a 1960s edition of Home magazine, part of the Salt Lake Tribune's Sunday paper. Since then, the phrase has been adopted by the state and its local powder hounds. It's been added to Utah license plates, marketed by our ski resorts, and even faced a lawsuit from Ringling Bros and Barnum and Bailey Circus because it sounded so similar to their trademark phrase, the greatest show on earth. Regardless of its past, the phrase has become near and dear to the locals and visitors who travel up our mountain canyons to recreate in Utah's light and dreamy powder. In fact, despite the COVID-19 pandemic, Utah's 15 ski resorts saw a record-breaking 5.3 million combined visits from last year's 2020 to 2021 ski season. There's no doubt more people are recreating in Utah's mountains and resorts during the winter seasons, through a combination of more locals moving in and out-of-state visitors. But at some point, the question of sustainability has to arise. While this conversation isn't completely new, recent years have presented some striking signs that are worth noting. With our state and much of the West facing severe drought levels, record temperature highs being recorded this summer, snowfalls starting later in the winter seasons, and increased traffic congestion up our canyons during peak ski days sparks some major concern. Regardless of where your personal opinions fall on the issue and how much climate change is affecting Utah's snow, at the very least it's worth understanding the information ourselves about the future of Utah's snow. In this 2-episode series, I spoke with various voices in the climate and Utah ski communities to get a better grasp of the current situation, trends, and concerns regarding the future of Utah's snow. After all, if we really do have the greatest snow on Earth, it's worth ensuring its longevity for the future generations to come. I'm Trencel. We'll be back after this short break.
Advertising can be one of the hardest parts of running a business. Audience in Motion is here to help. Arm your business with our state-of-the-art ad tech priced to fit budgets of all sizes. Contact your local Audience in Motion representative to learn more today at audienceinmotion.net.
At Jewelers Mutual, we're a little obsessed with jewelry. Obsessed like auctioneers with talking fast.
50, we're gonna fit sold.
Pop stars with auto-tune.
Yeah.
And dentists with asking questions.
So, how did he propose?
After they've put their hands in your mouth.
Great.
Yes, we've made jewelry our obsession for over 100 years. We love it so much we named our kids Ruby, Amber, and Opal.
Venti soy latte for Opal?
At Jewelers Mutual, we insure jewelry and only jewelry, which is why people who are also obsessed with jewelry trust us with theirs.
The voice you heard at the beginning of this episode was Brad Rutledge, one of the co-founders of the Wasatch Backcountry Alliance. You'll hear more from his perspective in the second episode. But first, I wanted to better understand why we have the greatest snow on Earth, and is climate change having an impact on the snowfall we see in our mountains, specifically in the central Wasatch Range. I first talked with KSL TV's resident expert, meteorologist Grant Wayman to have him explain Utah's winter weather patterns and where he sees the future of our winters going.
Yeah, Grant Wayman, W-E-Y-M-A-N, and I've been a meteorologist since about 2001, been at the station since 1999.
Utah has the greatest snow on earth, and it's been coined, it's been put on our license plates. Can you explain, why that happens? How do we get this super light, dry, fluffy powder that falls in the Wasatch Range?
In a nutshell, we have obviously very dry snow here being in Utah, but it's not necessarily the driest, but it's this combination of very, very dry snow and abundance. We get a ton of snow, in particular in the Cottonwood Canyons, those resorts, because of the nature of the elevation, the way the canyons are kind of situated in terms of topography. So you've got very dry snow. You've got a ton of it, right? Alta averages 500 inches a year. And then the way it kind of situates, generally, you've got somewhat heavier snow. It usually gets a little lighter as it continues to snow. So in terms of someone who likes to ski in powder, it's pretty ideal conditions.
The Great Salt Lake causing this lake effect snow, does that have a correlation?
Definitely, yeah. Lake effect is something we all know about living here. The amount of snow from a lake effect storm is small in comparison to what the mountains get through the year. However, generally at the end of a storm, we can get lake effect snow, which adds some very light snow to the already big total. So yes, lake effect snow certainly does play a role also in getting some of that really good light snow.
Based on your 20 years of witnessing the weather patterns, what general trends have you seen regarding snowfall and winter season length?
I've got some data in front of me to help me remind myself, but before I looked at the data, my quick answer to you would have been, I've seen it all. Since 1999, 2000, I can remember years where we just got kicking amounts of snow in the valleys and mountains, years where we had abundant snow, years where we were low. And so there's sort of highlights and lowlights along the way. And sure enough, the data kind of reflects that. So, just real quick, going back to say the last 10 years, I'm looking at snow water data as of April 1st in all these particular years. And we chose April 1 because that's usually when it counts, in terms of how much snow we've got up in the mountains. That's usually the peak, the pinnacle of of the snowpack. So in 2011, we had an abundant snowpack. It was higher than average. And then 2012 to 2014, it was a little under that. It was quite low in 2015. But then we had some above average years too, like 2017 to 2019. 2020, even though we started very slow, at least in terms of the amount of water in the snowpack, we wound up with a pretty decent amount, close to average. So the quick answer to your question is I've seen ups and downs.
The one thing I've noticed about Utah's weather is, it can change on a split second, and you have these crazy ups and downs on even on a daily time frame. But it's almost like even when you look at that, even a longer period of time, you see that same trend, just crazy ups and downs.
Totally. In fact, let's look at this. We're technically still in a drought, but we just got through one of our wettest Augusts on record, top number 7 in Salt Lake City. And in terms of Bountiful and Uinta lands, they wound up with their, get this, wettest August ever recorded on record. This in the middle of a drought season, that tells you how quickly things change. You're right.
Let's move into this topic of drought because it's been swirling around the state in the West this year a lot.
Right.
People are saying we've hit this pinnacle, and some have called it a mega drought. Can you talk about our current status of drought in Utah? We've hit some record high temperatures this summer. What does that all mean? And also, how is that correlated to then snowfall and our winter seasons?
Yeah, there's a ton of stuff to unpack in this question. It's really good. Just to kind of back up, the first part of your question about the drought and the impact. Yes, we are in the news business. We have talked about a drought year. It is not good, certainly. We have low water levels. We've had politicians saying this is the worst ever. We got to look at history, though, because I think we would differ with that statement if we looked at a couple of key times in history, which I think are really important that we need to look at. And one is going back almost 100 years ago, the 1930s. This was a key time in history where it was a journalist coined it the Dust Bowl. And we're talking about impact, not just in our state, but the whole West and frankly, the Midwest, which saw record dry years, a long duration drought, record high temperatures in many states, and farmland that was lost. Now, a lot of that was due to poor farming techniques and whatnot. However, a big portion was due to the hot temperatures and dry seasons we had. You cannot overlook the 1930s in terms of impact and what happened. And what it meant to Utah in those times. 2 of our top driest water years ever occurred in the 1930s. Our driest water year on record was, and this is at Salt Lake City, by the way, 1933 and 1934. We had 8.16 inches of water. That is like half or close to half of the normal, which is about 15 and a half inches. So incredibly dry year. It still stands as our driest ever. As I looked at every water year of the 1930s, literally every year we had below average precipitation. Huge impact all over the nation. Salt Lake City, very, very dry. 10 years of it. And I do throw this out there because this was 100 years ago. Talk of the global warming threat and all of that didn't even exist at that time. And then we cannot forget the late 70s, second driest water year on record, 8.19 inches of water. However, as dry as we went up with our wettest ever on record, 1981, 1982. People who lived here at the time will tell you the flooding we had then was literally the worst we have ever seen. State Street was a river, and I'm not exaggerating, for 3 days. They had to build a bridge over State Street. Water kept flowing out. There was flooding all over the state, mudslides everywhere. The Great Salt Lake was above its banks. It's spilled into the desert. It just tells you that in the last 100 years, we've had awfully dry periods, even more significant than now, and we've had incredibly wet periods as well.
Going by that data, maybe right now we're kind of starting to enter into one of those drier seasons and periods. It is almost like every 30, 40 years.
Yeah, and in terms of like that decade, again, the 30, nothing has come close to the 30s, thankfully, since that time. That really just stands alone as a dry series of years. 78, 79 was a very dry year, but we tend to have a good year, maybe a couple of bad years, a couple of good years. So if you were to look at a graph, it looks kind of like a roller coaster. I would say, if anything, that is normal for us to have abundance and then dry, abundant years. And that has continued. To tie that into the latter part of your question about, what does this mean, in terms of this coming snow season? The funny thing is, history shows that just because we've had a very dry year doesn't really tell you anything about the next year. And in fact, we're entering a La Nina year. The thinking is that we'll be in another La Nina season. For Utah, it doesn't mean anything. It means that we could have a wet year or a dry year. So the prediction for this year in terms of snowpack may have absolutely nothing to do with the year prior. We could certainly use a good year or a bonus year, and that's what we're hoping to get.
So one of the other things is our reservoir levels are way below average currently. With a situation like that going into a winter season, does that have any effect?
Usually one season will kind of piggyback on the other. If we've had one low year followed by another low year, that's really even more devastating. If we go through the season with another low runoff next spring, boy, that's really not going to be good. You don't want 2 bad years in a row because the lake levels were already low, and now they're going to have even less in the tank, so to speak. That said, if we can get we have seen this happen in history, as I mentioned, a good year and a bad year. If we can get a decent runoff, even an average amount next season, or hopefully an abundant, an above average snowpack and runoff, then I think we're going to be just fine. Then we'll see the water levels either about the same, if not a little higher, to close to normal. And then we'll all kind of breathe easy in terms of our water use next year.
Really, that kind of just stresses the importance of our winter seasons, and that There's a lot of trickle down effects depending on how much snow we get. So if the natural kind of trend of, let's just look at Utah, is these ebbs and flows, do things like our increasing population, all this new infrastructure being built in the valley, more waters being used, more emissions, things of that nature, does that then also concern you at all in the idea that it might cause more of these valleys or more extreme valleys or more extreme peaks? Do you see any correlation there?
This is going to depend on who you ask, right? You're going to talk to some scientists, and a lot of the stories you hear are going to be under the thought that yes, our human involvement, so to speak, is playing a very big role in our climate. You'll have other scientists that say there may be some involvement there with our own emissions, but at the end of the day, overall trends of peaks and valleys and common occurrences like that are far more important into the equation than what we're putting into the air. So I'm under the camp that there may be some effect, but I am not going to believe that our current state of emissions or any prediction there is going to have any dramatic effect on the amount of snow that we've seen. I'm not sure that we're ever all going to agree on how much we're playing a role in our Earth atmosphere, but boy, let's do what makes sense, right? We don't want to live in pollution. Let's do what we can to keep things clean, but let's do it reasonably. What things that are within reason, within cost.
Anything else you would like to add before we sign off?
Yeah, I think it's important that we throw this out there too, and I'd love for people to do some research on this. Going back to the 70s again, boy, there are countless articles at the time. Some of the greatest atmospheric scientists actually believed that we were heading for another ice age. The scientists of the day believed that we were heading toward global cooling. Now, this is the greatest, scientific minds at the time in atmospheric scientists. And there are several articles, Time Magazine articles, you name it. They're out there. And I encourage people to do that research because it's important to look at our history in terms of what we know has happened, but it's also important to see what scientists were thinking through the years. And we're talking about 30 or 40 years ago with theories of something that is completely opposite of what the mainstream is thinking now. I'm not saying anyone was right or wrong, but I think it's important as you hear, in particular, dire predictions in terms of our Earth and climate, that you need to look at history and see what scientists were saying years ago and put that in perspective, because we do know that through time, as we learn more, as we make more studies, scientific knowledge is going to change, right? We just know it. Just to remind listeners, climate is years of weather, right? 20, 30 years of a particular weather. And yes, climates do change, but weather and climate is different. An event like we're seeing this summer is not climate, it's weather. It's something that happens in a year's time is a weather-related issue. A strong hurricane like Ida the other day, that's a weather issue. That's weather. That's not climate. So we need to just kind of remember the differences there. When you hear a story, any story in terms of science or anything else, kind of look at where it's coming from, do your own research, look at history, and let that help you kind of decide where we're at and where we're heading.
Dr. Robert Gillis. He is a professor at Utah State University, also the director at the Utah Climate Center. So first off, thank you for taking the time to come chat with me.
Pleasure.
What can you tell us about climate change in Utah, and how is it affecting precipitation levels? How would you kind of generalize what's going on currently?
Well, I guess the key message is that the annual average temperatures have risen by more than 2.5 degrees Fahrenheit since the beginning of the 20th century. Warming is actually particularly evident as an increase in very warm nights and a below average occurrence of very cold nights over the past 3 decades. And if you want to think about predictions, there are various emissions pathways that the IPCC, propose. But if we go with the historically unprecedented warming, which is projected to continue through this century, then you can see that trend just continuing as we go forward.
For listeners' context, the IPCC stands for Intergovernmental Panel on Climate Change, and it's basically a body of the United Nations that provides scientific information relating to human-induced climate change. So looking at future predictions, are we looking at another 2.5 degrees Fahrenheit increase within the next century?
So it gets a little bit tricky when you start to look at regional, projections, because some areas, that's on average 2.5. Some are actually larger than that in terms of the observational data, and some are below that, right? But certainly the trend is definitely going to be continuing. Whether it's an accelerated trend or not, that's a tough one to actually put your hat on.
And how is an increase of temperature like that going to play a factor into then our snowfall and winter seasons we see here in Utah?
So we did an analysis about 10 years ago on this and published a paper in the Journal of Climate, and we probably should do the analysis again. But what we showed at that time was that more winter precipitation was falling as rain and less as snow, right? And that means a decrease in the snowpack water storage. From what I have read in the National Climate Assessment, which has just been released, they have projected the same scenario. In other words, more precipitation will fall as rain instead of snow.
Can you explain for me where you're pulling this historic data from, and then how you use that to make future predictions?
Weather data has been collected for a very long time, some places more than others. In Utah, it's been collected for about 100 years. And of course, during those 100 years, the network of collecting stations has increased or has changed. There are some areas where we might have 100 years worth of data, and there might be some places where we have 50 years worth of data. In the analysis that we did, we only went back 50 years, right? Because statistically, that's enough to get or to show a trend and be, statistically viable. Okay, so we have the records. A lot of them were originally on paper, and then they've been digitized, and they're in a database. And get those records or pull those records from the database, then plot them as a time series and see, what has been happening. And of course, weather data is quite noisy. And so what you end up doing is you end up smoothing the data. You might do a 5-year average, or you might do a 10-year average. And that picks out, the overall trend. And your listeners have probably seen this recently in the news, where with the COVID-19 epidemic, they show how the data is sort of fairly messy, but in order to see the trend, they do a 5-year average or a 10-year average. You've probably seen that on TV. I know I have.
Mm-hmm. One of the other things, I was looking around the Utah Climate Center's webpage, and the center was observing certain trends and behaviors of weather patterns happening miles away from Utah. And I think specifically I'm referencing some over the Pacific. And you were seeing a correlation to then patterns and trends in Utah. And so when you make those connections, you can also use that to make predictions or present. Can you give an example or dive into that a little bit?
Okay, so we're talking about climate, right? And obviously weather patterns. And the thing is that a lot of people don't realize what weather or climate truly is. Everybody knows that the equator is very hot and the poles are very cold, right? But the equator doesn't get hotter and hotter and hotter, and the poles don't get colder, colder, and colder with every advancing year. So what's happening to prevent that? Well, there's an exchange of energy between the equator and the poles. And it's that exchange of energy that keeps the equator roughly within so many degrees warm and the poles so many degrees cold. It's that exchange of energy that causes weather and climate. So what happens then, somewhere far away, the energy exchange there can and does affect the weather patterns in northern Utah, right? The one that's quoted on TV all the time is the El Nino La Nina, and that when it's in one phase, it makes certain regions dry, and when it's in another phase, it makes certain regions wet, right? It's really only viable for southern Utah, as far as we're concerned. There is another one which we discovered and published on, and that was called the quasi-decadal oscillation. It's in the same region as El Nino, but it's a different mechanism, and it affects northern Utahs. So the bottom line is that climate is global. What happens someplace else, and it can be many, many millions of miles away, and it has all this energy exchange. That energy exchange is transmitted northward and affects, for example, the jet stream in the northern latitudes.
With climate change and a general rising of global temperature, does that cause that energy exchange to be more volatile or more extreme? And then in correlation, why we're seeing more extremes as far as drought seasons or these. I think one of the things I've talked to people as far as snow in Utah is it's not so much the snowfall levels, but it's we're getting a massive storm all at once, and we're seeing more extreme storms versus in that past more consistent long storms.
So what is happening, if you actually look globally, is that the Arctic region is warming up big time. It's really warming up. So the temperature gradient between the equator and the poles changes as a result of that. So the transfer of energy changes as a result of that. Now, what is interesting is that in the paper that we published 10 years ago, we observed that what you said was the case, right? And that was that, we're getting less storms, but the storms that are coming in are more extreme, okay? And there's a shift from snow to rain. What caught my eye in the National Climate Assessment was that the models are projecting that the number and the magnitude of extreme precipitation events are projected to increase. And that doesn't coincide with the observations. So we'll just have to see what exactly pans out on that front. But the climate models, at least for Utah, are saying it's the same in terms of magnitude, but the number will be different.
One of the counter arguments someone would say about maybe the current drought we are in is that the natural kind of state of Utah's climate and historical data has kind of pointed at this is these peaks and valleys, years of above precipitation level and then below. What would you say to someone that's making that argument and looking at our current status today that would say, we're just entering into a valley. We need to kind of let it play out and things will bounce back?
Okay, that's true up to a point, because as I was saying, the quasi-decadal oscillation is what drives that, when you're saying the peaks and valleys, right? Drought has always been the case in Utah, and there's always been wet years, and they come in cycles, right? What climate change will do is it will exacerbate those cycles. So it will make them more extreme in whichever direction they are going. So you're going to get more extreme drought events, is essentially what I'm saying. Now, whether that will manifest as just simply deeper droughts in terms of precipitation, or will it mean deeper droughts in terms of temporal existence, right? In other words, will they be longer? And that is something that's quite difficult for the models to project. I do think that droughts are a serious threat in Utah because the intensity of naturally occurring droughts and the frequency and severity of wildfires are projected to increase in Utah. Yes, they're right in principle, but the system is being exacerbated by the climate change.
So you're saying that the extremes will get more extreme. Mm-hmm. Will the frequency increase? So we'll see those extremes will be happening more often?
The models are suggesting frequency will increase.
Okay.
So the whole point is when the frequency increases, you don't get a chance to recover as much as you should, because it does take a while for a drought to recover, because you've got to refill the reservoirs, you've got to refill the aquifers, etc. What
would you say is some of the major causes then to human-powered climate change? And also, can you kind of bring it to a local level for people that live here in Utah? With Utah changing so much, like infrastructure and population increases, how does that accelerate climate change or global warming?
It's simple. It's all about pumping carbon dioxide into the atmosphere. And the more you do it through industry or cars or whatever, then the atmospheric CO2 increases, the more energy is trapped on the planet, and that energy has to be redistributed, and it gets redistributed as we've previously been discussed.
How much stock or confidence should we be putting in these models and these future predictions when it comes to things like snowfall levels in the future and warming?
At the end of the day, when you publish a paper, you have to show and prove your results, right? So you have to show your methodologies, and then you have to prove or back up your results. The bottom line is that maybe we have 2 or 3 reviewers review a paper in the scientific method, which is quite a low bar if you think about it. 2 people, right, saying your work is definitely credible or not credible. What happens next is when your paper is published, it goes all over the world. And everybody in your field potentially can try to disprove your results, right? Or your methodologies. And they try to do that. And the more people that can do that, then the more credible your work is, okay? So that's one aspect of what you just asked, which is the science. So then what also happens is that when you make a prediction, you also assign confidence limits to that. And you say how confident I am or what I've done is likely to happen. So we're actually saying we really don't know within certain confidence limits what is going to go on here. but we're confident that something will happen, right? And we can say that with 95% confidence or even more, even 99% confidence. The models aren't limited by science. They're limited by our knowledge of various processes going on in the atmosphere and the oceans and the ice and on the land. And we're gaining more and more information or more insight about those all the time. That's important. So the models are not perfect by any means, but we have a certain amount of confidence in the projection that we're given. The other aspect to it is that we have two sets of data. We have the observations, of which in many cases we're very confident of the trends. And then we have the projections. And if they both align, you have even more confidence in making statements about what is likely to happen in the future. So your confidence goes up. When we go back and look and run the models in the past, then we can predict the observations in the past really rather well, which gives us even more confidence for predicting them in the future. And one last aspect, which is a little bit more subtle, these models that you're talking about are highly sophisticated models, and they are run by different governments all over the world. There are about 24 of them, right? And they are very complex, and they are run on high-performance computing systems. And if you give each model the same scenario, in other words, predict the temperature of the planet out for the next 40 years, you give them exactly the same input data, you tell them now predict out 40 years, you will get slightly different results from every single model. And you can mathematically show, and it was a French scientist or a French mathematician in the past who showed that if you run the same scenarios but different models, and then you clump them together and take the average, you actually get a very, very good result.
What are the models saying about snowfall and winter season length in Utah?
So they're just simply saying more precipitation will fall as rain instead of snow. So that has implication for the ski season, right?
Right.
They haven't made a definitive. It looks like the season will shorten because you're not getting that snow until much later in winter. We used to get it started in November, and now it's happening somewhat later. And
we
what's
really saw
more,
that last year too.
Yeah, we saw that last year. The other thing that's significant is that come the spring, the temperatures, both the minimum temperatures, especially the minimum temperatures, are much warmer earlier on in the season. So that melts the snow earlier in the season. So that's shrinking down the potential ski season.
Where we really get into trouble is when we have a lot of these severe valleys, meaning drought seasons below precipitation levels, hitting us 1, 2, 3 years in a row. And that obviously just has an incredible trickle-down effect, and it becomes harder to then recover. What do you advise that are some concrete steps we should be making as a state to be more prepared for these peaks and valleys and these drought seasons?
Right. So if you're forewarned, you're forearmed, right? If you have an idea about what's going on, you're forewarned. Now, again, we're saying what is likely to happen, and we have a lot of confidence in that. But you could come up with 4 or 5 scenarios where you say scenario 1 is the least impactful scenario, and scenario 5 is the most impactful scenario, right? In terms of, say, precipitation, okay, or the cycles. So what do if you're clever about it, is you say, okay, we've got a little bit of uncertainty here. We've got a number of scenarios that we could possibly go down, which go from good to bad, right? Let's watch over the next 5 to 10 years and basically find the scenario that we go. Which scenario are we following? And once you know that, right? You start to gain more confidence and you can start to think about what you want to do. Now, Utah is interesting, it's getting more water, certainly in northern Utah, but more of it's coming as rain. So you have to think creatively how you would capture that rain, because it's a very different system from capturing the snow or using the snow as your water resource. The second thing is, you just have to start factoring in demographics. What's happening in Utah population-wise? Well, it's increasing. That means then there's more demand for water by urban populations. So then that has a trickle-down effect, because 80% of the water used in Utah at the moment is agricultural use. And so you're going to have to start to think about a shift from agricultural to urban use. And that may have implications for agriculture, that it may have to use the water that they have, which potentially could be less, more efficiently. So there's all sorts of ramifications that are, come about as a result of a shift from snow to rain and an increasing population. The big thing, of course, are wildfires as well. And if they factor in the future too, do you follow a scenario that California is having at the moment, or, do you have mitigating effects now ahead of time, knowing what happened to California? Do you start treating the forests in a very different way for the future to prevent wildfires? And let's remember that 80% of wildfires are started by humans. You can see how the web we start to weave. The climate change is going to cause us to think differently.
Going back to those scenarios, one being the least impact that climate change has, 5 being the most extreme. Right now in 2021, do we look at those scenarios and say, let's shoot for somewhere in the middle to start implementing new technologies or policy to mitigate those effects? Or are we not even there yet? Are we more, like you said earlier, we should just still be watching the trends and looking at the data?
Well, I can tell you that we are going down the worst case scenario at the moment, both globally and regionally. A lot of people won't like that, because you might have to make some very significant changes which might affect, for example, the Utah economy. So what do? You then have to say, okay, let's agree to mitigate somewhere along the line. We're not going to go full hog and, what Dr. Gillis says, but we're going to do some things that will mean that further down the line, it's not going to be as bad.
Is there a point of no return, and are we close to that?
Well, the IPCC report that came out from the United Nations says exactly that. We are very close. We're in the red zone. If we don't make major changes now, then all bets are off. That's what the report is dire. The thing about climate change and global warming is that it has to be an international solution. Everybody has to play a part in that solution. So governments, local, regional, federal, can all do their part. We all do our part, and then countries have to all do their part. We have to get carbon dioxide concentrations in the atmosphere down. Otherwise, things are going to be very different, and it will be different in different ways all over the world. Some places will actually do quite well, believe it or not, and some won't.
Where would you point someone to go look at some of this data or to do personal research?
So I would suggest the National Climate Assessment that is produced for the US. So that's produced for every single state. It's mandated by Congress every 5 years. and the most recent one has just come out. The other source is the the IPCC, the International Panel on Climate Change, and they have just produced their major report to the United Nations. Those are the two solid scientific sources that I would suggest people look at. And there may be parts in there that are difficult to translate, and they're more than welcome to engage the Utah Climate Center for some more information or for some explanation.
Thanks for listening to this in-depth on the future of Utah's snow. If you would like to view any of the data referenced in this episode, you can find links in the show notes. Coming up on part 2 of this series.
And I think of particular note to Save Our Canyons, we're very concerned about not just the quantity of our water, but the quality of our water.
We have a lot of really fun summer activities, but we love skiing and snowboarding in the winter, and the health of the environment directly impacts us getting to do that. And so climate change and facing those issues and being aware of them and talking about them and doing what we can to combat them is really important to us at Snowbird. We want long winters. We want consistent winters. We want to be able to rely on consistent snowfall.
At Jewelers Mutual, we're a little obsessed with jewelry. Obsessed like auctioneers with talking fast.
50, we're gonna fit
pop stars with auto-tune. And dentists with asking questions.
So, how did he propose?
After they've put their hands in your mouth.
Great.
Yes, we've made jewelry our obsession for over 100 years. We love it so much we named our kids Ruby, Amber, and Opal.
Venti soy latte for Opal?
At Jewelers Mutual, we insure jewelry and only jewelry, which is why people who are also obsessed with jewelry trust us with theirs.